Question number 5, exponential models. $10,000 is invested in an account compounded continuously. So that means that I'm going to use the following formula. The principal, the prime value times base E of the interest rate times the number of years. So 10,000 is invested. The rate is 3.08, which means that the one I'm going to use is 0.0308 after 7 years. Now, remember, personally, I like to use that as a function, so I will put a of 7, and then you just type that in your calculator. 10,000 times base E of 0.0308 times 7, and you've got 12,406.06. We're talking about money, so by default, you round up to the nearest cent. Now, what should be the annual interest rate to reach $10,000 in 7 years? So I want this A of 7 to reach 20,000. So I'm going to take the same formula, but this time it's R, which should become the unknown value. So I'll have 10,000 times base E of the rate that I don't know times 7. And I want to reach 20,000. So this is actually pretty basic. I'll have base E of 7R equals 20,000 divided by 10,000, which is 2. I cross over the natural base, it becomes ln of 2. And finally, R would be ln of 2 over 7. And ln of 2 divided by 7 is 0.09902, which is roughly 9.9%, let's say. For B, I'm going to use the following chart. And for this one here, I'm going to work with the Raden or Raden 222, and the half-life given to me is 4 days. What does it mean? That means that the when you apply, so I've got an original amount times E times R, it takes 4 days to reach half of the original amount. And I will have those two on each side of the equation cancelling, and therefore I will have 4R equals ln of 1/2, and R equals ln of 1/2 divided by 4, and that would be roughly, let me do that, ln of 1/2 divided by 4, and I'll have negative 0.1 17328, which is roughly, in terms of percentage, 17.33% of decay. Next question. What is the rate of decay of the radium-226? I am given the half-life in years. So I am going to use the very same formula, and you can eventually, once you are comfortable with it, as long as you know where it comes from, skip this first step and directly start at this one here. So I've got base E of the half life times the rate, which will be equal to 1/2, which means that R would be the natural logarithm of 1/2 divided by 1600. And if I've punched those numbers in my calculator, I would have ln of 1/2 divided by 1600. I have negative 4.332 times 10 exponent negative 4. This E negative 4 means, it's the scientific notation, means times 10 exponent negative 4. So as a decimal, I will have 0.0004332. And in percentage, that would be 0.04332 percentage of decay. Next question. This time I'm going to work with the iodine. So the half-life is not given to me, but I have a problem here. I start with 60 grams. So that's my starting value. And I'm going to use the continuous formula for decay. And after 12 days times the rate, I will be left with 7.5. So to get the rate, I'm just going to isolate R. It's exactly the same thing, right? Then I will have 12R equals the natural logarithm of 7.5 over 60. And finally, R would be ln of 7.5 over 60 divided by 12. I punch those numbers, and I would have ln of 7.5 over 60 divided by 12, and I've got negative 0.1733, let's say, which is, in percentage, 17.33% of decay. And that will allow me to answer the final question: what is the half-life? So, once again, I've got the original amount, A0, times base E of RT equals half of the original amount. So those two will cancel. I've got the rate of decay, which is negative 0.1733, times the half-life, and therefore this half-life T will be ln of 1/2 divided by negative 0.1733. And this half-life will be ln of 1/2, 0.5, divided by negative 0.1733, as you can see, to the nearest day, 4 days.